Okay, YouTube, in this video we are going to be looking at the recursion form of the rule for the nth term of an arithmetic sequence. And so in the last video we looked at the definition of an arithmetic sequence. That'd be something like maybe, I guess we could start at 3, and maybe if I went up by 4 every time, it'd be 3, 7, then 11, and then 15, and so on and so forth. This would be some arithmetic sequence where our first term is 3, first term here, first term A1 is 3, and then we have our common difference here. It looks like our common difference is 4 between all of the terms. But anyways, that being said, what we want to do is come up with a rule that would tell us how to find any term in this sequence. That is, if I said, how can I find A3? A3 should equal 11 here. What's the rule that gives us that? So the recursion form, remember that recursion forms of formulas basically always say that what you do is just get a given term here. In this case, we usually refer to a given term as the nth term. What this says is add d to the term in any position to get the next term. So in other words, what this says is the nth term is always equal to the n minus 1th term, or the previous term plus d. So we say the nth term is equal to the prior, I'm going to write previous term, just generally speaking. In this case, previous term plus whatever the common difference is every time. So for instance here, we could write the rule for this by, first of all, and this is always very true, giving the first term. And the first term value in this case is 3, but in general I could say, well, then the nth term is always equal to the n minus 1th term, or the term before it, plus the common difference. And because our common difference is 4, then we could just say, well, take the term before it and add 4. So in other words, we would say we would start our sequence at 3. I would put 3 in right here, and I would get 3 plus 4 as the next term, which is 7. Then I would take that 7 and plug it into the rule again, and we'd say 7 plus 4 is 11. Okay, and then we'd plug 11 into here, and we say 11 plus 4 is 15, and so on and so forth. So let's just do this. I want to know that if I'm given a recursion form of a rule, that I could actually go write some terms in that. That's a good place to start. So let's look at this. It says write the first 6 terms of the arithmetic sequence in which A1 is 100. So we are told our first term here. We say A1 is equal to 100. And so I'll write that down also, 100 comma. And then what this says here basically is that the nth term is equal to the n minus 1th term, take 30 off of it. So in other words, to get the next term, you take the term prior to it and you subtract 30. So in other words, if I were to take 30 off of this, this is our common difference right here that is being stated up here in this general statement. But if I were to take 30 off of that, when we say, well, then I'd have 70. And if I were to take another 30 off of this, our next term would be 40, and so on and so forth. We'd say 10 would be our 4th term, negative 20 our 5th term, and negative 50 would be our 6th and final term that we wanted to write here in this sequence. But that's the recursion form of the rule for an arithmetic thing. Cheers.